Okay, so we're in our final lesson for this unit. Yeah, we're only having 3. Skill 37 is about creating parametric equations. So first we graphed parametric equations. They were given to us. Next we were given parametric equations and we eliminated the parameter, which gave us just a regular equation. And now we're going to create a set of parametric equations given a normal function. So you can see here in your foldable it says a set of parametric equations for any curve defined y equals f of x is, and then it gives you 2 equations. And this is just a fancy way of saying that the set of parametric equations for a function is x equals t, and then you evaluate your y function at t. And as long as t is in the domain, you're good to go. Okay, so what does all that mean in terms of actually completing a problem? Well, let's start with an example problem. So we're going to find 2 sets of parametric equations for the parabola whose equation is y equals 9 minus x squared. Okay, so they've given us a function, they've even told us it's a parabola, and they want us to create 2 sets of parametric equations that will create the same parabola. And you can actually make infinite sets of parametric equations because every set you make is going to have like a different speed. You'll see what I mean here in a moment. So in our notes up here, it said x equals t. That's the easiest one to do. You just choose x to equal whatever you want. The easiest one is t. So if you've chosen that, then to make your y equation is very simple. You substitute. So you're going to have y equals 9 minus, and in place of x, you're going to put t. So x equals t, so substitute x with t. And that's it. You just create a set of parametric equations. And this one will look exactly like that, except it's going to have a direction. And we would have to graph it to see what that direction is. But that's basically it. You have to start with choosing a substitution. Now, let's create another one. So another one would be x equals, but instead of doing t, because that would be the same one, let's do 2t. Well, whenever you go over here, instead of x, you're going to put 2t, so you'll have 9 minus 2t squared. Notice I put that in parentheses because it was the x squared, so now 2t is actually being squared, which will mean that y equals 9 minus 4t squared. The difference between these two is that this one is going to be moving more quickly because here x counts with time. 1 second passes, 2 second passes. But here x is double the amount of time, so when amount of time passes, like 1 second, then x is 2. And then by the second time, the second that occurs, x is 4. So it's moving more quickly. And I'm going to go ahead and highlight here to show that substitution. And that's pretty much all there is to it. Now there is a little trick that you have to be careful for, like a curveball, so to speak. So let's go ahead and write this down. You must choose a substitution for x that allows x to take on all values in the domain. And this is really important. So kind of like yesterday whenever we were talking about eliminating the parameter and we had to be concerned with restricted domains because we didn't want to make the graph bigger than it should be. Well, here it's just the opposite. We don't want to make the graph smaller than it should be. Okay, so here's an example of a bad substitution. Say we wanted to get crazy, we're like x equals t squared. Well, that seems all great and everything, except for the fact that the original problem, y equals 9 minus x squared, there was no restriction on the x. X could be negatives or x could be positives. But over here, with this substitution, you've restricted it to x is only going to be positive numbers. There's no way to plug in a t value, positive or negative, and ever get x to be negative. So you're basically cutting off all the negative values. And according to your original problem, they should be there. So this is a poor substitution. So it's a poor choice because it eliminates all negative x values. And we don't want to do that. So stay away from squareds. I can't really think of anything else that's going to give you fits like that. And there's certainly nothing in the book. So I think that's the only one you have to watch out for. Don't do anything with the squared because it's going to limit your x values. And the only reason why you'd want them to be limited is if there was a restriction put on this in the first place.